हेलो एवरीवन, वेलकम टू आवर चैनल यूनिवर्स। इलेक्ट्रिकल इंजीनियर्स यूनिवर्स में आप लोगों का स्वागत है। सो टुडे आई एम गोइंग टू डिस्कस ऑन वर्किंग ऑफ इलेक्ट्रिकल ट्रांसफॉर्मर एट नो लोड कंडीशन एंड loaded condition. So let's start. So here we can see this is a transformer and we are give a alternating supply in this transformer. So when we are give a alternating supply in the transformer, then a alternating current is flowing through this coil. This is a primary coil of this transformer. So when a alternating current flowing through this primary coil, then a flux is generated, and this flux link with this coil and EMF induced in this coil. So now we can write, so at no load condition, the main flux, that is phi t, equals to phi m sin omega t. So when this flux link with N1 coil, then flux linkage is occurred, that is denoted by lambda 1 equals to N1 phi m, and due to that a EMF induced, that is denoted E1, that is d lambda dt equals to d dt of N1 phi m sin omega t equals to N1 phi m cos omega t. So when we are giving a AC supply in this transformer, then in primary coil a alternating current is flowing, and due to that in primary side the flux is linked with primary coil, that is N1, and due to that a flux linkage is occurred, that is lambda 1, denoted lambda 1 is equal to N1 into phi m, and due to that induced EMF induced in this primary coil, that is denoted by U1 is equals to d lambda dt is equals to d dt of N1 phi m sin omega t equals to N1 phi m cos omega t. So in this manner, this flux also link with this secondary coil, that is denoted by N2, and due to that in this secondary side also a EMF induced. So now this for primary side, in secondary side also this main flux, also link with this secondary coil, so link with N2 coil, and due to that flux linkage is occur, that is denoted by lambda 2 is equals to N2 into phi t. Okay, so due to that also in secondary side EMF is induced, that is denoted by E2 is equals to d lambda 2, that is lambda 1 by dt equals to d dt of N1 phi m, N2 phi m sin omega t equals to N2 phi m cos omega t. So we can see how how a EMF induced in a transformer at primary coil and as well as secondary coil. So now we can write E1 T is equals to d lambda 1 by dt equals to N1 phi m cos omega t equals to, sorry, N1 phi m omega cos omega t equals to N1 phi m omega sin omega t plus 90 degree. In RMS value, we can write N1 phi m 2 pi f by root 2 equals to 4.44 f into phi m into N1. This is for primary side. And in secondary side, d lambda 2 by dt equals to N2 phi m omega cos omega t equals to N2 phi m omega sin omega t plus 90 degree equals to so in this value, in RMS value, equals to n2 phi m 2 pi f by root 2 equals to 4.44 f phi m n2. So we can see how the EMF induced in a transformer at primary coil as well as secondary coil. So now we can write, write E1 RT by E2 T equals to N1 phi m omega cos omega t by N2 phi m omega cos omega t. So this will be cancelled out. So equals to E1 t by E2 t equals to N1 by N2 equals to E1 by E2 is equals to N1 by N2. So this is called, this equals to A. So that is called trans ratio. That is called trans ratio. And E2 by E1 equals to N2 by N1 equals to K. That is called transformation ratio. So remember this point. So N1 by N2 is equals to, that is called trans ratio, and N2 by N1, that is called transformation ratio. That means secondary side turn by primary side turn equals to K, that is called transformation ratio. So now the question, So when which side are step up or which side are step down? How we can identify that? So now, if if n1 is greater than n2, then in primary side induced EMF is more than secondary side induced EMF. So that is called step down transformer. So when in primary side turn is more than secondary side, then in primary side the induced EMF is large than secondary side. In that case, we call this is a step down transformer. Similarly, when in secondary side turn is more than primary side, then in secondary side induced EMF is large. In secondary side induced EMF is large than primary side. In that case, we are called this is a step up transformer. So in that case, we are called this is a step up transformer. Okay. So now we are see the phasor diagram of transformer at no load condition. So at no load condition ट्रांसफॉर्मर का जो फेजर डायग्राम होता है वो हम देख लेंगे. So the induced EMF that is lag by 90 degree with main flux. So we can draw in this manner. That is our main flux, that is Im, and this is our E1, and that is. So in this phasor diagram, we can see this is a step down transformer. Why this is a step down transformer? Because in this phasor diagram we can see, also in our diagram we can see, in primary side the number of turn is more than secondary side. In primary side the number of turn we can see in our diagram, in primary side the number of turn is more than secondary side. That's why we can call this is a step down transformer. So in our phasor diagram we are also see the magnitude of E1, that is more. E1 is more than E2. So that's why we can call this is a step down transformer. So now we are discuss at loaded condition what happen in the transformer. So now we are connect a load in our secondary side. So a load. So you can see in our secondary side we are connect a load. And when we are connect a load in our secondary side, a current will flow in secondary coil. So when we are connecting a load in our secondary side, due to that, a current is flowing to this secondary coil. So that is I2. Okay. And due to that, a secondary flux is generated uh, in this coil. So we can draw. So due to flowing a current in our secondary coil, a flux is generated. That flux oppose the main flux, and this flux direction is oppose the primary flux. You can see here, this is main flux, this is main flux in this direction, and in our secondary flux, that is phi 2, this direction is upward. So the secondary flux is oppose the main flux. So the secondary flux oppose the main flux. So the resultant flux phi r equals to phi 1 minus phi 2. So case 2, at loaded condition, so when we are giving a load in secondary side, then due to that a current is flowing through this secondary coil, and due to that a flux, that is secondary flux, that will generate, and the secondary flux oppose the main flux. Due to that the resultant flux will decrease. Let's see. So we are when our load is increased, okay, so when our load is increased, then in secondary side the current I2, that will also increase, right? So our load when our load is increasing, then the current drawn in secondary side, that is also increase. Okay, that is also increase. Now our load is increased, then current also increase, then phi 2, that is increase, and resultant flux, that is decrease, right? So when we are connect a load, then due to that secondary side a current is drawn, due to that secondary flux is generate, and this secondary flux oppose the main flux. Due to that the resultant flux is decrease, right? Right? Yes or no? Yes or no? But this is not happen, right? So in this transformer the flux is always constant, that is maintained. Otherwise transformer cannot work. Okay, so now we are write our EMF formula, that is 4.44 F into phi m into n1. So we know that phi, that is proportional to V by F. Phi flux, that is proportional to V by F. So in our supply the voltage and frequency always maintain constant. So हमारा जो सप्लाई होता है कांस्टेंट होता है, उसका जो वोल्टेज लेवल और फ्रीक्वेंसी लेवल वो चेंज नहीं होता है. सो द voltage and frequency, that is constant. Okay, due to that the flux, the main flux, that is not change. Okay, okay, if V by F ratio is constant in our supply, then the main flux will not change in transformer. Okay, if the voltage and frequency is not change in our supply, if V by F ratio is constant in our supply, then our main flux also constant in our transformer. Okay, so now we can write so phi total equals to phi m plus phi 2. Okay, so mmf we know that flux equals to mmf by reluctance, so that's why we are write this mmf by reluctance. we are dividing N1 in both sides. So here we can see that is N1 by N2. That means that is trans ratio. Okay, that is equals to A. So we can write I1 equals to Im plus I2 by A equals to Im plus I2 dash. That is secondary current with respect to primary side. So I2 dash it is a secondary current with respect to primary side. So now we can write at load at no load condition I2 equals to 0, I2 dash equals to 0, I1 equals to Im. Okay, and at loaded condition I2 not equals to 0, I2 dash not equals to 0, and I1 equals to Im plus I2 dash. So here Im that is magnetizing current, and I2 dash that is secondary current with respect to primary side. So now I conclude here. Thank you. Thank you everyone.